These exam questions about binomial expansion just come to show that sometimes the fact that you are solving an exam question does not mean that you are solving a hard question. Just look at this question 2. This is from an October-November paper from 2008. It says, expand 1 plus x, the whole thing, times square root of 1 minus 2x, in ascending powers of x, up to and including the term in x squared, simplifying the coefficients. And you have 4 points for this question. So what do you have actually to expand? You have to expand this square root. Okay, don't forget that square root of 1 minus 2x is 1 minus 2x to the power of 1/2. So this is the part that you have to expand. I just paused this over here, and I'm going ahead and expand this. So again, is the first 3 terms you want up until the term with x squared. So you have these 3 terms, in which the first one is just 1, right? The second one is nx. Your n is 1/2, so that's 1/2 times your x. By x, they mean the expression, and the expression is actually minus 2x. So that's n, 1/2, times minus 2x. And then the last term is n times n minus 1 over 2 factorial times the expression that you have there square. So n times n minus 1 over 2 factorial times this expression squared. Then just simplify, and this is the result. Now, to get the question that they ask is the outcome of multiplying. Let me see again. I kind of forgot what they were asking. Expand blah 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 up to and including the term in x squared. Okay. So here you have the result of the expansion. Okay. So now you just cross multiply to get everything that you need. You actually will get a term with x cubed. You don't want that. You just want this up until the term with x squared. Okay. The actual term with x will cut out, so you just have these 2 terms. Okay, simple enough. 4 points. Let's see another one. June 2009, paper 3. It's question 5. When 1 plus 2x, the whole thing, times 1 minus ax, the whole thing to the power of 2/3, where a is a constant, is expanded in ascending powers of x, the coefficient of the term in x is 0. Find the value of a. And I'm reading on purpose this question too, and they are going to understand why in a bit. When a has this value, the one that you got over there, find the term in x cubed in the expansion of this, the same expansion, simplifying the coefficient. Why did I read the second one? Because if it was just for the first question, if I want the term, if I'm just looking for the coefficient of the term in x, all I needed was to expand this on the first 2 terms, right? Because this is going to be multiplied by that, and the only way that you are going to get, as a result of this multiplication, terms with x is when this one multiplies with a term in x with this expansion, and when this 2x multiplies by the 1 on this expansion. So all I needed was to just expand the first 2 terms, and I would get my result. But the second question asks me something about the term with x cubed. So I took the first question just to expand the whole thing until the term with x cubed, because I'm going to use this later on, and then helps me out on the second question. Okay? So I'm just expanding this. So 1 plus n times the expression plus n times n minus 1 over 2 factorial times the expression square plus n times n minus 1 times n minus 2 over 3 factorial times the expression cubed. Okay? Then just simplify the whole thing, and here you have the coefficients in terms of a. And what do I know? I know that I need to get the term with x when this is multiplied by that. So I'm now going to substitute this but by whatever I expanded, and I multiplied by 1 plus 2x. I just cross multiply, get everything that I got, and then I put together like terms. So this is the term 1, this is the term with x, this is the coefficient of x squared, and this is the coefficient of x cubed. I know that the coefficient of x must be equal to 0, right? That's what the question says, right? 0, yes. The coefficient of the term in x is 0. So I know that this over here, the term with x, must be 0. So this means that a is minus 3. All right? And now, because I bothered to do these other two terms, note that to answer this question, this is completely irrelevant and this is completely irrelevant. I could have stopped over here, right? But now, in this question, I need to find a term in x cubed in the expansion above, simplifying the coefficient and figuring out what that coefficient is now that I know the value of a, now that I know that a equals minus 3. So I just go to the expression of the coefficient of x cubed, I substitute a by minus 3, and I get the actual coefficient, minus 10 thirds. Last question, Spring 2011, paper 31, and it's question 1, probably the simplest of them all. Expand cube root of 1 minus 6x in ascending powers of x up to and including the term with x cubed, simplifying the coefficients. Okay, nothing to know here, okay? This is 1/3, just apply the expression, okay? N times the expression plus n times n minus 1 over 2 factorial times the expression square plus n times n minus 1 times n minus 2 divided by 3 factorial times the expression cubed. Just simplify and simplify. They don't even bother to ask the range of values for which this is valid, all right? You just have to show this.